Okay, we should be up, so I'm gonna ask you to do me a favor.
Yes.
I'm gonna
So,
ask you to send to go on my YouTube channel and just send the stream to the Discord.
uh, uh, talking about the link.
Yeah, just the link.
Where's the link?
Just go on YouTube.
Okay, okay, okay. Where's your channel?
Just my name,
Miguel
Martinon.
Just Miguel Martinez.
Martinon.
All right, Miguel no space.
There's a space between Miguel and Martinon.
Okay, Martinon.
Yes.
Okay, Martino.
You should say that I'm streaming.
Uh, yes, study session.
Okay. Let me check if I can view it and if my audio is fine. Okay, yeah, it's going.
Okay.
It's done.
Main one, right?
Yeah, the main one. Just yeah, send it to the main 104 Discord.
Main one, right?
Yeah. So it's the B1. Perfect. This is
Yep, yep,
live.
yep.
Feel free to join and we will answer questions. Okay, that should be good enough. Correct?
Yep.
Perfect. Okay, so let me set the 6 minute timer up. Three, two, one, go. 6 minutes, 6 hour. Let us begin.
Yep.
First, we're going to start
All
with
right.
this. You can still see my screen, correct?
Let's see here. Let me. Yeah.
Perfect. Test. Uh, Options. Multiple choice only. Standard grading. Create new test. Okay. When xi and xj represent something, designating whether projects xi and xj have been completed, the following special constraints may be formulated. Uh, these are these are when they represent binary variables, correct?
Mhm.
Yep.
Why?
Because
Or
it
actually,
is
this is
saying
just a term.
it's saying yes or no. Is a one or two, one or zero, correct?
Yeah. Oh yeah,
Other
because it's just those two, right?
yeah,
Yeah.
other
Okay.
criteria include time and cost. Neither time nor cost are necessarily linearly related to distance. Okay. The criterion to be minimized in shortest route problem is not limited to distance or through the term shortest. It is used to describe the procedure. An assignment problem is a special case of a transportation problem in which hmm, I'm gonna go with B. Do you have any objections to this?
Nice.
Do you?
What about D? Would D be?
It is not
But
limited
I'm
to
not
term
sure.
distance. Is used to describing the procedure. Hmm.
Um, I mean,
I'm gonna go with D.
actually, no. Go with B. Go with B. Go with B. Let's go with B.
Depict decision nodes. Okay, so is that circles, diamonds, squares, or what are they? What depicts the decision nodes?
Uh, decision nodes. Isn't it the one that we were talking about the tree? Does this have something to do with the tree?
Yes, has to do with the tree.
Uh, um, no, were those were were they circles?
Are they
God,
what?
were they
Circles?
circles?
Why do you answer
Almost.
that?
No, I'm just. Oh my God, my memory is not that good right now. No, because I just remember the tree.
Well,
Yeah,
then what do you
were they
think it is?
circles? Jesus. It was. I think it's. I might be square rectangles. Oh, Jesus, come on. Goldfish memory, come on.
Goldfish memory. I like it.
Yeah, god damn it. I have a goldfish memory. Jesus. You know what? I'm just gonna go with the squares and rectangles. Go
Okay,
with that.
we'll go with that.
Yeah.
Upper bound on the expected value of any sample or survey information. That is what the. Okay, let's see here. The estimated value of perfect information provides in the states of nature provide in expected value of a decision alternative decision tree is. That's what expected value perfect information provides. The upper bound, correct?
Yeah.
How do
Makes
you know?
sense. It makes sense.
Oh, don't give me that. I'm just asking you. How do you know?
Hmm?
How do you know?
I how do I know? No idea, but it makes sense. And I know it's not the decision tree. I know it's not. I just process elimination.
Okay,
That's how I know.
that
Because
works.
I know it's not the decision tree. I know it's not the states of nature. And then the third one, well, you know,
Sure thing.
I don't think it makes sense. Yeah.
Okay, xij is greater to lij. What is that? Linear programming special cases minimum shipping guarantee from I to J. LP special formulation cases the objective is maximizing profit or revenue. LP formulation special cases total demand exceeds total supplies. What do you think this is? This is a formula.
What about D? Would it be D?
Projects I and J are mutually exclusive.
Hmm.
Why do you think D? Just let me ask you that. Because you can't say process of elimination here.
No. No, it's just a guess.
It's just a guess.
It's just a guess.
Okay.
Yeah. What about you? What do you think, Miguel?
Well, given that it's greater than, I'm gonna go with it exceeds. No modification of LP formulation necessary. hmm Actually, I think you might be right about this one. That it was D. No, because that doesn't make sense. Where would the L come from? That's fine.
Yeah, it's fine. It's fine.
No modification of the linear programming formulation is necessary. That is what? Total demand exceeds total supply? No.
No, it's not. It's not any.
It's one of
I don't think
these.
it's any.
No, it has to
The
be.
one of the exceeds.
No, no, no. Just one of these are true.
Hmm. Will it be the unacceptable route?
Why would it be an acceptable route?
Because it says no modification of LP formulation is necessary. I don't know. It's just
I go with A.
minimum shipping guarantee. Okay.
Does that make sense?
Mm, be the special case minimum shipping guarantee from I to J. Oh, okay, okay, yeah.
Good. Read the next one. Out
The
loud.
pay
We're
of the
recording.
I might actually read. I'm just reading it. Between the expected value of decision alternative, the pay of them might actually occur. Decision analysis?
Sure. Regret table or an opportunity table. That is when the Minimax regret approach requires the construction of these. Exceeds total supply. No, 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 no. When minimum supply. Hmm. I think it's when you're maximizing profit or revenue. It's this one. When you need a dummy ship. Or would it be this one? Actually, it's gonna be this one. Which means that this is wrong.
Are you sure about the dummy ship?
Yes, I'm pretty sure. Amazing profit or revenue. Okay. Xj is less than or equal to xi, or xj minus xi equals to 0. Wouldn't that be a conditional?
Yep.
I'm asking you.
Yeah, it
Okay.
is.
Okay. You got another one?
Good decision analysis includes.
What does it include?
Is this risk analysis?
A good decision analysis includes risk analysis that provides probability information about favorable as well as Yes. But if that's the case, didn't we answer risk analysis earlier?
No, that was decision
Oh, you're right.
analysis.
Okay.
Yeah.
A chronological representation of the decision problem.
Decision tree, right? Or is it?
Yeah, that's what a decision tree is.
Yeah.
Okay. I'm gonna go with these are examples of network problems. Yes or no?
Decision. Yeah, sounds good.
Okay. Remove the corresponding decision variable. Mm, these two are wrong on the right. What about the left?
Go with the corresponding decision. That looks like that could be the answer.
What?
The B.
B?
Remove the correspond. Actually, wait. Let me think about it real quick. Remove the
This one's a thinking
corresponding.
one.
Remove the corresponding decision variable. What do you think, Miguel?
Well, what do you think? What do I think? I'm asking you a question. I mean, I don't know the answer.
Uh,
We're gonna learn the answer.
me neither.
Hmm.
Yeah. So
Uh,
if I pick one, I'm just gonna guess.
go for it.
It might be A, the unacceptable route, but like, then again, that's a guess.
It's fine.
So
All variables whose values are restricted to 0, 1. If all variables are restricted to be 0 or 1, the problem is called a 0, 1 binary integer linear programming. Oh, binary variables. If only a subset of variables are restricted to be integers, the problem is called a mixed linear integer programming problem. Give it the next one. What's the next one? Say it out loud, please.
list the minimum payoff for each decision. Choose a decision with the maximum of these minimum payoffs.
Okay, what is your answer?
With the maximum of these minimum payoffs. I have no idea.
Hmm.
What do you think?
I just realized something. Remember when we went to the no modification is necessary one? Give me a second. Where is it? Yeah. So
Yeah.
this is exceeds total demand. Did I click it? Oops. Total demand. Thank you.
Yeah.
So what did you get for this one again?
Oh, I told you I have no idea.
Hmm.
Yeah.
Choose a decision the maximum with these minimum payoffs.
Minimum. Maximum of this minimum payoff. Total demand exceeds total supply.
Special transportation problem or general purpose linear programming codes. Uh, Those would be a capacitated transshipment model, or shipment problems can be converted to linear. Oh, transshipment problems can be converted to linear transportation problems and solved by that.
Is concerned with determining the maximal volume of flow from one node called the source to another node called the sink. Um,
I'm gonna go with the maximum flow problem.
one flow. Yeah.
Last one.
Um, minimize the total cost assignment of m workers to m jobs, given that the cost of worker I performing job J is was that C I J. It assumes all workers are assigned and each job is performed.
Yes, but which answer is it?
What's not on this verification? Wish minimize. Um, assignment problem of season which no. I think it might be A or A or D. That one, yeah.
Okay, so if we took this naturally on an exam, we would got a C here, which isn't terrible. It is good.
Can I see what we got wrong? Okay, so that's the right answer. An assigned
Mm-hmm.
problem is okay. Let's go over the ones we got wrong.
Here's the next one.
Okay. Okay.
It's risk
Oh,
analysis.
it was risk analysis. Okay, did I get it backwards?
Mm-hmm.
Ah, man. Okay. Oh, wait, what? They were both risk analysis?
Yeah, I think so.
What?
Yeah, they both are.
Whatever. Oh, okay, never mind. The minimum payoff. Okay.
It was
Okay.
a. Oh well.
Okay, yeah.
Well, we'll take this again
I mean,
in a little
yeah,
bit.
it was either one of those anyway. So
Mm-hmm.
yeah. Yeah. Okay, you were saying, Miguel?
We'll finish. We'll take these again later.
Hmm.
For now, we're gonna start with one of the problems.
Yeah.
Good.
Yeah.
Baller. So let's start here with problem one from the practice homework, from the practice assignment he did in class. You remember it? Do you?
Sorry. What was that?
Do you remember problem one?
From from the last meeting.
Yeah.
Shoot. Did he post it?
Yes, he did.
Hold up. Let me bring it out. Let me bring it out.
Okay, let me post it on here. Okay, so it is the following questions refer to a capital budgeting problem with 6 projects represented by 1 variables being x1, x2, x3, comma
Okay, so he did. Okay. Uh,
x4, comma x5, comma x6. Good? So now we got to start with part A.
Okay.
Write
Yeah. Yes.
a
Yes. Yes.
constraint modeling a situation in which two of the projects one comma 3 comma 5 commas and 6 must be undertaken. Okay? So let's start with just A really quickly. How would you write
Yeah.
this? Do you know? Because I do. No, I'll give you like a minute to try to answer this one.
So it will be let me look at this following body problem by 0 to 1 variables. This is a binary variable, right?
Hmm.
0 to 1 variable. So that would be x1 plus x2 plus x3 plus x4 plus x5 plus x6 equals to 2. Well, actually, wait, no, no. We're
Close. You're
going
very
with
close.
sorry. We're going with A, right?
Hmm.
Constraint
Now
modeling
we're doing
in
A.
which two of the product. Okay, we'll do x1 plus x3 plus x5 and x6 is equal to 2. Is equal to 2.
The correct
Yeah.
answer is x1 plus x3 plus x5
Yeah, I need
plus
to read my
x6
question.
is equal to 2. You were correct.
Yeah, yeah, yeah.
So now let's do the next half. Well, the next part. B. Write a constraint modeling a situation in which if projects 3 and 5 must be undertaken if, comma, they must be undertaken simultaneously. That's a weird way to phrase it. I know how to write this. Do you?
Um, it says project 3 and 5 must be undertaken. They must
Yes.
be undertaken simultaneously.
Yes.
X3 is equals to x5.
Okay. What's the other way to write that?
There's another one.
There's two ways to write it.
X3 is equals to x. Is it x3 is wait no. Greater than or equal to 5?
x3 minus x5 is equal to 0.
Oh, right. Yeah, okay.
Good?
Yeah.
Perfect.
Wait, x3 minus x5?
Yes.
Okay,
Minus.
okay.
Time to do the next one. C. That is, write a constraint modeling a situation in which project 1 or 4 must be undertaken.
But not both.
They, oh, but not both.
Mm, it's is it like uh x1 is equals to 0 and x4 is equals to 0?
Mm-mm.
No? Or x1 is equals, I don't know, x1 is equals to 1, x4 is equals to 1? No.
It's this. There it is. x1 plus x4 is less than or equal to 1. Does that
They
make
said,
sense?
but not both though.
I know.
But okay.
It can't be both because, as you know, x1 and x4 must be either 1 or 0. This is a binary problem.
Okay.
Binary. So, only
Alright.
1 or 0.
I need to okay. These I need to work on these terms just
Next, D will be write constraints modeling a situation where project 4 cannot be undertaken, but, oops, I mean, not but, unless projects 1 and 3 are undertaken.
Project 4 cannot be undertaken. Oh.
Do you know it?
Project 4 cannot be undertaken unless.
1 and 3 are.
Is it x1 is greater than or equal to x4, and then x3 is greater than or equal to x4?
You are correct.
Okay.
2x4 and then x3
Yeah, I
is
remember
greater than or
that
equal to
one.
x4.
Yeah, I remember. Yeah, I remember. I remember now. I remember that one because nobody could get that one, and then the professor had to step in.
That
Yeah,
makes
that's why I
us
remember it.
that makes us look
Yeah.
bad. Okay. E, the last section of this question right here. In addition to the requirement in part E, assume that when projects 1 and 3 are undertaken, project 4 also must be undertaken. How would you write that one?
Comment in part D. Assume that one. Ooh. Well, that's. Jeez, what was this one again? Oh man, I actually don't have no idea.
So what you'll do, E, is as
All right.
follows. E, it'll be x4 greater than or equal to x1 plus
Plus x
x3. But we're missing something. What are we missing?
zero is equal to 0.
No.
Um.
Minus 1. Why do we make it minus 1?
Why?
Because no matter what, x4 has to be 1 or 0. This is a binary problem.
Mhm.
Otherwise, this would equal to 2.
Oh, okay, okay. Let, let me go to the question again. Mm, okay, okay, okay. Jesus. Okay,
And
gotta read these
that is
problems.
one
Yep,
question, sir.
I know.
Now we're going to do question 2. Good?
Yep.
Okay. Hmm. So let's just get rid of all of this.
Yeah. Go ahead, go ahead.
Problem 2. It's the Grave City problem. In the relocation of several police substations to obtain better enforcement in high crime areas. The locations under consideration together with the areas that can be covered from these locations are given in the following table. Okay, so it'll be potential locations for substations, and then we go dash areas covered. So potential locations will be simple, be A, B, C, D, E, F, G. As for areas covered, well, we're gonna have a lot of areas covered. It'll be 1, 5, 7. Then the next one will be 1, 2, 5, 7. And then after that, we will have 1, 3, 5. And then after that, we're going to do 2, 4, 5. And then afterwards, it's going to be 3, 4, 6. Following along, we get 4, 5, 6. And then finally, we have 1, 5, 6, 7. Good?
Mm-hmm.
Okay. Now that we have that, we're only going to do part A because part B is impossible to do without an Excel, okay?
Okay.
Formulate an integer programming model that could be used to find the minimum number of locations necessary to provide coverage to all areas. Good? So now, what do you think we're doing here? Hello? Can you still hear me?
Yeah.
What are we doing in this problem? Have you been paying attention at all?
Yes.
Okay. Then what is the plan? Do you even know how to do this problem?
No,
Okay.
I do not.
Okay. And then let's just start from the beginning. First, it's asking us to do a few things. First, here's my mouse. We need to find the min. Based on this table, do you think you could tell me what the min is? What are we trying to minimize?
Let's see here. We are. Let me. Sorry, so give me. Let me think about this one. Because if we're trying to minimize them, right? We're gonna have to do the formula thing, right? The
Yeah,
standard solution.
yeah, we're doing a formula like we do in every
Uh-huh.
single one.
Yeah.
Okay. Well, for the formula, because I don't want to waste
I
everyone's time.
Yeah, so that's the one with the x
Yeah. So it'll be
x
x what?
for area A, right? Like it's x well, if I go back to the list, it's like x 1, I think, x something, and then you do like less than or equal to the area, something
Uh,
like that.
it's this.
Oh, that's the min.
A plus x f. There should be an e, by the way.
Yeah.
xf plus xg. Make sense so far? That should be a
Yep.
capital G.
Mhm.
Alright, so now that we have that, oops. What exactly, how do we make the subject to section? What are the areas?
Formulate programming. Enter that could be used to find the minimum number of locations necessary to provide conversion. Oh yeah, this is the one I was talking about where you do um x1 or yeah, I think it's like x1 and then x5 and then x7 is less than or equal to area 1, right?
No.
Or no?
Okay, so as you can see, these numbers are here, right?
Yeah.
So notice how this is 1, 1, 1, and 1 over here. 1 on G, 1 on A, 1 on B, 1 on C.
Yeah.
So the way I would write this would be as follows. Be subject to, and then from here it would be XA plus XB plus XC plus XG would be greater than or equal to 1. And the reason for this is because all of them cover area 1.
Yeah.
Now that you know that, I think you can figure out how to get the other 7 numbers, correct?
Yeah.
Okay.
Yeah.
Well, I'll write them down for the people, but I think you guys can figure it out.
Yeah.
Let's
Yeah, just
be
follow the list basically.
XD is greater than or equal to 1. Then we have XC plus XE is greater than or equal to 1. Then we'll have XD plus XE plus XF is greater than or equal to 1. And then of course we have XA plus XB plus XC plus XD plus XF plus XG is greater than or equal to 1. That's for area 5. And then for area 6 we'll have XE plus XF plus XG is greater than or equal to 1. And then finally we have XA plus XB plus XG is greater than or equal to 1, and this is for area 7. So you can see 7, 7, 7, 5, 5, 5, 5, 5, 5, which is why this one is the longest over here. Does that make sense?
Yeah.
And then what are the
Yeah.
other constraints we're missing? Do you know what the other constraints are? Let me open up the problem again.
Yeah.
What are the other constraints? We're missing a few more.
How many here, let me see how many do you have? Alright, let me see here. You have B and D here, you have C and E.
To anyone who's watching this, I'm gonna give you guys a bit of help here. You guys can
Yeah.
take the Quizlet that I posted. It's just under my name. In fact, I'll post it in the description, in the chat right now. take that Quizlet and then try to make a quizzes out of it while we wait for him to solve it.
The last one? Are you missing the last one? The
What is the
one
final constraint?
I um it will be XA. Mm, see here. XA, XB, XT. No, no, no.
Hmm.
No, go ahead.
Okay.
Go ahead. You can do the last constraint.
Final restraint was. I can find it. Here's my thing. It'll be x I as an x integer is equal to 0 or 1, comma I is equal to a b comma ellipses g. The ellipses just means all letters from B to G.
Okay.
And that's your final constraint. Does that make sense?
Yeah.
So in reality, problem 2 is just a test of do you know how to write a constraint? And do you know how to
Yeah.
write the programming problem?
Mhm.
Now we got problem 3, which is genuinely menacing looking, but it's not that bad. Okay. Problem 3. The Delta Group is a management consulting firm specializing in the healthcare industry. A team is being formed to study possible new markets, and a linear
Oh, okay. Oh, yeah, makes sense. Okay.
has been developed. Wait, what happened?
No. I was I totally get the last constraint now.
What is the last constraint?
Yeah.
Well, can you explain it to me?
Well, it's just in the well, because I read the question.
Okay.
It's in the question.
Yes. F cannot figure out how to incorporate from 3 departments and uses the following variable definitions. There'll be x1 is equal to the number of employees selected from department 1. x2 equals the number of employees selected from department 2, and x3 is the from department 3. Okay? Do my forward slashes make sense to you?
Yeah.
Good. So
Yeah,
now,
don't worry about it. Yeah.
gotta show the staff how to write constraints that will ensure that the team will consist of 3, 5, or 7 employees. The following integer variables should be helpful. Okay? And then the following integer variables are y1 is curly brace 1 if the team is 3, colon 0 otherwise. y2 at, oh, there should be equal sign here. Oh, did I click insert? Yeah, I did. Do you know what I'm doing? Hello, do you know what I'm doing?
Yes.
What am I doing?
I mean, you're just writing the questions right now.
That's true, but you should still be. You could still ask questions. Maybe elaborate on the questions if you have any questions on it.
Yeah.
Zero otherwise. Now that we have that, I gotta ask you, what exactly is the question asking us?
Uh, the question show. Well, it's telling us to show the staff how to write the constraints that will ensure that the team will consist of 3, 5, or 10 employees.
Well, how do we write the
Yeah.
constraints?
Hmm.
Do you know?
Yeah. No.
No? Okay. So in this instance, first, you gotta know something. The team size is equal. Okay? Therefore,
Mhm.
when you write it out, it'll be as follows: x1 plus x2 plus x3. That is
That's the
because
team.
this is because team size is equal.
Yeah, that's the team size, right? X1 plus X2.
Yep. Because team size is equal.
Mm-hmm.
Now that we have that, we have to do our little bracket, our curly brace. So we have x1 plus x2 plus x3 is equal to 3y1. Where does my y1 come from?
It's from that question over there with the Y ones. If the team is 3, 0 otherwise, I'm assuming.
Okay.
Yeah, that's
So if that's the
the
case,
best fit I could get.
what are my next two variables?
Um,
Plus what? Plus
no,
what?
plus 5y2.
And then
Yeah, and then we'll open up the list again. I can see. I can't see. 7y3 plus
correct.
7y3.
But we're missing something. What are we missing?
Another constraint.
Yep.
Uh,
What is the constraint we're missing?
Mm, does it have something to do with the Y?
Yeah.
I'm assuming it's just y1 plus y2 plus y3.
What's next?
Equal to 1.
Y1.
Hmm.
Why is it 1?
Um, is it because the um, I don't know, because I don't think it's 0,
It is
so I
1.
just went with 1.
The reason it's 1 is because we need to make sure that only one size is selected.
Okay.
That's the reason.
Okay.
And that's how you do problem 4. Does that make sense?
Yeah.
Now let's go back to problem 3. Now we're going to do problem 4.
Okay.
Problem 4. The following
Which one is this one?
Payoff table shows profit for a decision
Oh.
analysis problem with two
Uh,
decision. What?
oh, this is a decision tree, right?
Mm-hmm.
Yeah. Ah, okay. I know I struggled on this one, so gonna have to take a back seat here, Miguel.
Oh, you're just gonna give me free reign? Sure thing.
Go ahead, Miguel. Yeah, because I know I struggled on this one.
Okay.
Make it faster for the viewers too. So yeah, I will just listen and learn.
Sure thing. First, you gotta cite everything here. States of nature for this one would be 250.
Ugh.
Then we'd have 100. Then we'd have 25. And then, of course, here we go to 100, 100, 75. And now it's asking us A, construct the decision tree for this problem. Alright, let's do this. So to construct the decision tree, you gotta draw the damn tree, obviously. Now remember that squares and circles are different. This is our decision, and then we gotta go up here and up here, and we make these D1 and D2. Good? We add these circles here to represent our states of nature, and that would be S1, S2, and S3. 3. And the same goes for this one. S1, S2, and S3. Perfect. So now we have to plug in our numbers here. Up here was 250. Here was 100. Here was 25. Then up here was 100, 100, and 75. Okay?
Yeah.
But we're missing something. What are we missing?
I said D1, D2. Yeah, S1, S2, and S3 in there. Um, are we missing something?
Well, the answer is no. I just wanted to test if you were paying attention.
No. We're not missing anything. I
Okay,
think we're
good.
good. We're covered. Yeah.
Yep, here's your tree. Then we gotta go to B. If the decision maker knows nothing about the probabilities of the three states of nature, what is the recommended decision? Using the optimistic, conservative, and minimax regret approaches. Well, for this one, we have to look at the maximum profit. So in S1, which one is greater, 250 or 100?
250.
S2, 100 and 100 equal the same. S3, which one is
Yeah.
greater, 25 or 75?
75. Yeah.
Okay. Well, in that case, assuming he doesn't know, we'll do, this is the optimistic approach. We're starting with the optimistic approach. We're going to do this one. The minimax. You gotta write the tables now. B. What happened? Did my screen freeze?
You're good.
Hold on, my screen froze. Screen is frozen. Damn it.
Oh. Okay.
Okay, we're back. my stuff.
Is it still frozen or is it
Yeah,
not coming up?
my screen froze straight up.
Oh shoot. You can
Uh,
restart it if it's still
no, I'm not gonna do that.
yeah, because I see you just drawing
Yeah, that's
lines.
not me.
Oh, that's not you?
No.
Well, I see lines. Are you drawing the
Yeah,
optimistic?
I finally fixed it.
Okay, okay.
So the optimistic approach involves us choosing by the maximum number. So, looking back at our notepad, what is the recommended decision using the optimistic? Be 25. So decision here, and over here will be max profit. Well, it's gonna be D1, D2, be 250, and 100. The maximum
Yeah.
decision, the optimistic approach says we pick 250. Good. And then from here, we got to go to the conservative approach, which is the maximin. Okay? Conservative approach states the lowest of the minimum profits. So in D1's case, we have what number?
In D1's case,
Yep. What is our lowest maximum profit?
for D1 it's 100, right?
It's 25
Oh wait, oh you're talking about like from
minimum.
never mind, from D1. I was
And the
thinking like
second one will
X1.
be 75.
Yeah.
Okay? Well, there's no zero there. Well, from here, easily enough, we pick 75. Why do we pick 75?
It's the highest.
Highest of what?
Highest of between the D1 from the minimum profit.
Correct.
Between 75 and 25, yeah.
Correct. Now we gotta pick the next one. First, we gotta get rid of certain section. First, I'm gonna erase all of these stray lines that I have no idea how they got here. How did the O die? Whatever.
Mhm.
I don't know how the O went away, but sure. Okay. So now that we're here, we gotta do the D, the regret or opportunity approach. The regret approach. What's the regret approach? Do you remember?
The what?
The regret or opportunity approach.
Regret opportunity approach? No, I do not remember. I told you that's why I'm just taking a back seat here.
Okay. Well, I'm gonna remove this tree because I'm assuming you all have it written down.
Yeah.
Good. Very good. Let me just remove all of this and go back. So for the regret opportunity loss approach, we have decisions. And then here we have S1, S2, and S3. And then we have D1, D2. So the way we do this is we take the highest number of the two picks here. So the highest number is between 250 and 100 is 250.
Uh-huh.
And then this one will be 250 as well. But then we subtract it by the other number, so it's be 100. So it'll be 250 here. This will give us 0 and 150
Wait, why do we subtract the 250?
because it's the bigger
250?
number. So for S2,
Okay.
we're gonna do 100 because that's the bigger number, and 100. But we know that 100 minus 100 is 0, and since both are equal to 100, we're just gonna write 0 and 0 for both. Okay?
Okay.
Then for S3, we know that 75 minus 75 will give us 0, And we know that 75 minus 25 will give us 50. Good? So in reality, for D1, D2, S1, S2, S3, we have 0, 0, 50, not 500, 50. And then for top, we have 150, 0, and 0. Good? So now we need to pick the minimum of the maximum regret. So, what is the maximum regret for D1?
Okay, 50, no?
The maximum regret for D1 is 50, and the maximum regret for D2 is 150. Therefore, we pick 50 because we want to minimize our regret, and
Yeah, so
50
yeah.
is less than 150. Therefore, we select 50.
Mm-hmm.
That's how you do B.
I'm still wondering about the 250 minus 250. Why'd you pick 250
Because it's the
on the
biggest number.
D1? No. On the D1, you said you did 250 minus 250.
hmm
Why'd you pick 250 minus 250? Couldn't you pick like 250 minus, like the one on D2, like minus 100?
Well, the reason it's minus 100 is because on S1 of D2, if you go back to the tree, it's
Yeah.
100, which is right here.
hmm Yeah.
So 250 and 100, which is the bigger number?
It's 250.
That's why 250 is in both. Then we subtract by what's actually here. 250 and 100. 250 will give us 0, and 100 will give us 150.
Oh, okay.
Make sense?
Ah, okay.
Perfect.
I see. Okay.
C will be this. Suppose that the decision maker obtained the probability assessment P of S1. Is decision maker one word, or is it serious? It's hyphened, okay. Right? Is equal to 0.65, comma, P probability of S2 is equal to 0.15, and probability of S3 is equal to 0.2. We must now use expected value approach to determine the optimal solution. Okay? Does that make sense?
Uh, Not at the least to me.
Okay. So, what this is telling us, let's look back at this. We have new information here. See?
Uh-huh.
We know that P of S1 is equal to 0.65, comma, P of S2 is equal to 0.15, and P of S3 is equal to 0.2. So, expected value of D1 is equal to 0.65 multiplied by what number? Because this is S1 and we're doing D1.
Multiplied by 250.
Correct. Multiplied by 250.
Uh-huh.
plus 0.15 multiplied by 100
Yeah.
plus 0.2 multiplied by 25. Then we'll use a calculator and get 182.5. Then estimated value of D2 is equal to 0.65 multiplied by 100 plus 0.15 multiplied by 100 plus 0.2 multiplied by 75. Good? Then we'll put this in a calculator and we will get 95.0. Therefore, the optimal approach is D1. D1 is optimal. Good? Did that make sense?
Um. Yeah. You just put in the D1. Yeah, using all these variables with S1, S2, and then yeah, you just add them all up.
Okay. Technically, you're
Mhm.
right.
And then you did the same thing for D2, right?
Yes, we did. Just to check, right?
Yes. Yep.
Okay.
And then you pick D1 because it's higher for the optimal.
Yeah.
Yeah. Okay. All right. Sounds good.
Good? Okay. Perfect. Okay. So now we gotta do part D. Which is what is I don't know what happened. What is the expected value of perfect information? Good? Well, we must get the expected value of perfect information. So first, we need to get the formulas. Make sure you have all of these numbers saved somewhere, because knowing where the numbers go is really helpful. So we know that the estimated value of perfect information is equal to estimated value with perfect information minus estimated value without perfect information. Good? Well, we know from part C that the estimated value without perfect information is equal to 1 8 screen, don't freeze on me please, 182.5. So we really only need to calculate estimated value with perfect information. Well, in a sense, we just take the biggest numbers from throughout the entire thing. So we have 250, 175. Why is VSDC opening? 250, 175.
Question.
So it'll be E. Why did this open? Close.
Huh.
Back to our regular schedule program. EVWPI will be equal to 0.65 multiplied by 250, because 250 is the biggest one, plus 0.15 multiplied by 100, because they're both the same, plus 0.2 multiplied by 75, because that's the bigger of the two S3s,
Yes.
is equal to 192.5.
Okay.
So the estimated value with perfect information, EVPI, will be equal to 192.5 minus 182.5, which will give us 10.
Mm-hmm.
And that's how you do
Looks good.
D. Good?
Looks good.
And now let's do the final of the problems and then do another Quizlet again.
Yeah. I'll be right back, Miguel.
Okay.
Yeah, just go fill the questions then.
Given that he's not here, I can just write these down more easily without having to worry about asking him. Problem 5, ladies and gentlemen, will be the following. Payoff table shows the profit for a decision problem with two states of nature and two decision alternatives. Good. So the states of nature, then we have decision alternative. Go here, S1, 1, 2, 3, 4, 5, S2. For here we will have D1 and D2. S1 will be equal to 10 and S2 will be equal to 1. S1 for D2 will be equal to 4 and S2 for D2 will be equal to 3. Fairly simple stuff. Now that we have this known, we must A, use graphical sensitivity analysis to determine the range of probabilities of state of nature S1 for which each of the decision alternatives use the largest expected value. The decision
Okay, I'm back.
of the decision alternatives. Okay. And then B will be suppose P of S1 is equal to 0.2 and P of S2 is equal to 0.8. What is the best decision using the expected value approach? Okay. So first, we gotta take into account problem 5, what exactly it's asking us. Well, let's do part A. We must use the graphical sensitivity analysis to determine the range of probabilities of state of nature S1 for which the decision alternative use is the largest expected value. Okay. Therefore, what we do is A, EV DI D1, my bad, EV D1 is equal to P multiplied by 10 because 10 is bigger than 4 plus open parentheses 1 minus P multiplied by S2, so this will be 1. And if you put that in a calculator, you should get 9P plus 1. And then B, not B, my bad. Then we have to do EV of D2 is equal to P4 plus open parentheses 1 minus P multiplied by 3 because S2 is equal to 3. And if you put that in a calculator, you will get P plus 3. And given that 9P plus 1, so now we do if EV D1 is greater than EV D2, we pick D1 and vice versa. And however, we're not done yet, given that this is a much longer section. So in essence, if we want to take the entire thing, in essence, 9p1 plus 1 is greater than p plus 3. And to solve for this one, we go minus p. We'll get 8p plus 1 is greater than 3. Or in other words, 8p is greater than 2. P will be greater than 1 over 4. Do you know how I got 1 over 4?
See here. That's 6. Whoa. Huh. I'm a little confused. Yeah, how'd you get 1 over 4? That's 8p. Actually, no. Yeah.
Good?
I'm dumb. Yeah. I got it.
Okay, so hence, if p is greater than 0.25, we pick D1. P is less than 0.25, we pick D2. And p is equal to 0.25, D1 or D2. That's how you would write A. Well, that in the previous section.
Uh-huh.
That is how you would make your decision.
Okay.
Now we're gonna do part D. Part B. Because there's only two parts to this one. Part B states, suppose P of S1 is equal to 0.2 and P of S2 is equal to 0.8. What is the best decision? Well, we choose 2. Because 0.2 is less than 0.25, so we just choose 2. Therefore, what we gotta do is plug them in to both. So P1, so EV of D1 will be equal to 9p plus 1. However, we pick 0 EV D2 equal to just p plus 3. However, if you look at these two numbers, and you know this is p for this one is p equals 0.2, and this one is p equals 0.8, then you know we pick this one down here, and to show it off, we get EV D2 is equal to 0. Hold on. Yeah, 0.2. I don't know where I got 0.8 from. Was it from the question? Yeah, P of S2.
There you go, yeah.
P of S2
Yeah, we got it from there.
Okay.
That's
2 plus 3 is equal to 3.2. However, if we go EV of D1, we'll do
Where'd you get 3 again?
from the 3 is from the question.
Okay.
From when we solved for A.
Okay.
Okay?
Mm-hmm.
Because let's look at E2 really quickly. EV of D1. Just to show off a difference. 9 times 0.5 is equal to what? 0.2.
9 times 0.2. Let me get my calculator.
1.8, I believe.
1.8. Yep.
Plus 1, it'll give us 2.8. Therefore, we pick D2.
Yeah.
3.2 is bigger than 2.8.
Mm-hmm.
And that is how you solve that one. That's all 5. Does that make sense to you?
Um, yeah, yeah, it makes sense.
Okay,
Yeah, yeah, okay, yeah.
I'm asking you, does it actually make sense? Just say yes or no.
How you do it makes sense, but if I do it myself, I'm gonna get I have, I have to practice.
Yeah, we all gotta practice
That's why.
this.
Yeah, yeah, yeah,
Let
yeah.
me actually
Yeah, you
read.
got the P plus three. Okay, you got it from the EVD two. That's why you got the plus three from over here. Okay, 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 okay. Yeah.
So it makes sense, right?
EVD. Yeah. Oh, actually, wait. Okay, wait. EVD 1.8, and oh, okay, 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 okay. Okay. 9p 0.2 is going by an a plus 1. Okay, okay, all right, now it makes sense. Yeah, yeah, just yeah, now it makes sense.
Okay. Well, now that we've done that, let's go back to the Quizlets for a little bit.
Yeah.
First, let's practice our misterms.
Hmm.
Okay. The set of all interconnected resources involved in producing and distributing a product. Supply chain?
Yep.
Good. Add a dummy origin with supply equal to the shortage amount, assign a zero shipping cost per unit. The amount shipped from the dummy origin in the solution will not actually be shipped. Exceeds
Is this
total
the
supply.
same one?
Yeah, it's the same ones we just
Yeah.
used. Transportation problems in which a shipment may move through intermediate nodes, transshipment nodes, before reaching a particular destination node. What is this?
Um. Move. Um. Banana balance shortage run problem. Would it be transshipment problems? But I'm not sure.
You're correct. Is concerned with finding the shortest path in a network from one node to another node.
Shortest path. It should be the shortest. No
Yep.
problem.
When xi and xj represent what, designating whether projects I and j have been completed, the following special constraints may be formulated. Binary variables. Can be used to develop an optimal strategy when the decision maker is faced with several decision alternatives and an uncertain or risk filled pattern of future events. What is it?
Most strategy. Basically, uncertain or uncertain risk field.
I'm gonna say it's
Optimal.
decision analysis.
Okay, okay.
What depicts chance nodes?
The will it be the circles?
Yes. Good.
Okay, okay.
Wait, where's that? Close this. Yes. Now let's go to the test again. For this
Yeah,
test, for this test, you're gonna do it, and I'll just fill it in, just to make sure you're getting it too.
yeah. Can be used the optimal strategy. Yeah, we just did this one. This decision analysis. If only a subset of the variables are restricted to integers, the problem is called
Can you please
a.
speak up? This is still being broadcasted.
Okay. Okay, you want me? Okay, you want me to read it? Okay. If
Hmm.
only a subset of the variables are restricted to be integers, the problem is called
Come on.
mixed integer. Hmm. Can be used to determine how changes to the following inputs affect the recommended decision alternative. Probabilities for the state of nature, values of the payoffs. Yeah, we went over this one. I think it's risk analysis. Is the ratio of BSI to EVPI. I am not sure about this one.
Give it a guess.
You want me to guess?
Yes.
Mm, no, that's not this river. Um, I would say the efficiency of sample information. The consequence resulting from a specific combination of a decision, alternative, and the state of nature is a consequence. Is it payoff?
Is that your final answer?
Yes. Is a graphical device showing the relationship among the decisions, the chance events, and the consequences. Hmm. Graphical device. I am not sure about this one. I told you I haven't gone over like the term, so I need some help.
Well,
There we
yeah,
go.
but the idea here is that you're gonna answer them, and then we'll go over what you missed. If you legitimately
Okay.
don't know, just guess.
Oh my god. Ah, relationship among the decision. Shouldn't the chances there? I'll go with multi-dimensional analysis. Hence, the maximum possible cost is minimized. The criteria, I mean, short drop problems are limited. Three commonly used criteria for decision making. If the payoff was in my god. Really don't know. No. I would say I would say it's D. We choose a decision that has the largest single value in the payoff table. Oh my god, I'm gonna get most of this wrong.
Come on, guy. Okay, look. If you get it wrong here, it's whatever. If you get it wrong in the exam, it's bad. So don't be afraid of getting it wrong here.
Yeah. We choose a decision that has the largest single value in the payoff table. Simon Simon Bell. Well, that's not it. Largest single value. Frequently decision make happen whenever would be used by us. Okay. I would be the optimistic approach would be used by an optimistic decision maker. Um, in a balance chart, the problem the total supply is equal to the total demand. Buying, when it becomes relatively easy to find a feasible solution. Balanced transportation problems are easier to solve. Um,
I have no idea what you said.
no, I'm just reading it like
Oh, okay.
must be buying. Let's see. Strategies. I'll just go with the balanced transportation problem.
Special
Special.
transportation program or general purpose linear programming codes.
Mm. A capacity transshipment model. Okay. A table showing pays off for all combination decision alternatives and SAS is yeah. Oh wait, payoff table.
Okay, good if you got that wrong. I was gonna get mad.
Oh no! So what you're saying is I'm getting most of it wrong. An LP in which all the variables are restricted to be integers is called an. Uh, I mean, it should be the add integer. Wait, hold up. Which I don't know. Wait, hold up. Yeah, let's go with that one. Add integer. Okay. Xj less than or equals to xi or xj minus xi is equals to. This is a conditional. So yeah, project J is conditional on project. Project J is conditional on project I. Other criteria include time and cost, neither time nor cost, and is necessarily linear related to distance. Oh, value on that. Yeah. Make a difference. It's the shortest route problem. Those control supply must make decisions such as will it be D?
Why?
Hmm?
Why?
No idea. Other. I am guessing at this point. That's why. Satisfy customer demand for a product at minimum cost. Hmm. Binary engineers. The expected value of a decision alternative. Minimum of the maximum regrets. Is the one correspond? Um, A?
Why?
Uh, I am not sure. Minimize the total shipping cost of transportation goods from M origin, each with a supply Si to end decision, each with a demand DJ when the unit shipping cost from origin I to a destination J is J. Oh, It's either A or C. Yeah, I'll go with A. Makes sense. Yeah, a model which can be represented by a set of nodes, a set of arcs, and functions associated with the arcs and or nodes. Network model. Next. Xi plus xj is less than or equal to 1.
Do you know it?
Project I and J are mutually exclusive. Hence, the minimum possible payoff is maximized. This again. Uh, oh, Jesus. I'll just go with C.
All right, time to guess. Submit test.
Uh,
That's a fail.
yeah, I know.
What'd you get wrong?
A lot, I know. Wait. Oh, okay. Can be used to determine how the change of inputs affect the state of nature balance. Okay. So, wait, so what was the answer? So the answer is
Sensitivity
sensitive and
analysis. Yes.
okay. Uh, influence diagram. Oh shit. Okay. So can I see that? Okay. Hence maximum. Okay. Hence maximum is minimized. Maximum. Oh, okay. All right. I know. Okay. Let's check out the other ones. We chose payoff table dot. Optimistic would use. No. Would use optimistic. Okay. Okay.
Does that one make sense to you? Okay.
No. Explain, please.
So the transshipment problems can be converted to a larger transportation problem and solved by this is literally saying this is how you can solve it.
Okay.
These are steps to solve rather than this which is trying to be a definition.
Okay. Okay. Other criteria include time and cost. The criteria. Okay. That's good. Wait, I see that one. To satisfy demand for at minimum cost. In general, supply chains are designed to. Okay.
It was B.
Yes. Can I check? Can I check something real quick? Can you go up a little bit? Not that one. Bit above network model. Above that one. Yeah. Okay. All right.
Well, given that this isn't a pass, iLearn tells you to retake it. So 3, 2, 1. Good luck with the midterms.
Okay.
I wouldn't let us in. Okay, whatever. You know what? We'll take one more test, okay?
Yeah. And then what?
And then we'll go do other questions. Homework questions.
Okay. Okay.
We're here for 6 hours, guy. Okay.
Yes, yes, of course. What's our break?
What break?
I haven't ate lunch yet.
Neither have I.
Okay.
Like, if you want, we could take a break at, well, whenever you declare it. How about 4?
4?
Yeah.
I was thinking 3 because I'm hungry right now.
Okay, so we'll do this last Quizlet, and then we take lunch. Deal.
Okay. Sounds good. Okay. Most typical approach, the conservative approach, the minimum max regret approach.
But you have to get 80 or higher, otherwise we take another one.
All right. Give me a second here. You're expecting too much from me. I have not gone over my terms yet.
Cynthia, this is being recorded.
Frequent decision makers. Approach. Oh, 3 commonly used criteria for decision making. Transportation. Oh. What are the examples of network problems?
Yep. It's kind of like Jeopardy now that I think about it. I give you the answer, and then you have to give me the question.
A conservative decision maker. Okay. A conservative decision maker. A minimax regret approach. What? Makers. Would be used by. Wouldn't it be just the conservative approach would be used by a conservative decision maker?
Yes.
Solve as a maximization problem. No, for each decision, the minimum payoff is listed in the corresponding of these minimum payoffs. The payoff enters the cost for each decision, and the decision corresponding to the minimum exceeds the number of tasks. Oh man, I don't know this one.
Come on, you got this.
For each, I will say C. Super guess. That's just a real guess.
Okay.
Extra agents simply remain unassigned. Number of agents exceeds the no, will be used by us. Would it be A? Oh wait, hold on. Not sign information. The number of agents exceeds the number of tasks. Yeah, I would say A, right?
Okay.
Makes sense. Oh, it's a graphical device showing the relationship among the decision, the chances, and the consequences. Influence diagram. Let the minimum payoff for each decision choose a decision with the maximum of this. Wait a minute. This is the same as the last question. Was it? Oh no. The list of the minimum payoff for each decision. Choose a
That was
decision with a
very
max.
random. Oh no.
Yeah, because this is the other question, the last question, right? The same question as the last one.
No, the
You
previous
go
question.
back up. Oh, if you go back, if you try to go back up. No.
No.
Actually, never mind.
What?
Never mind. I thought it was the same question as one of the first ones. Okay. Mm,
Well, what do you think it's
uh,
going to be?
Jesus. I don't know. Choose a decision with the maximum of this minimum payoffs. Would it be D? D or A?
You gotta
One
give
of
me the
those.
answer.
D. I'll go with D. One question includes time and cost. Neither time nor cost are necessarily linearly related to distance. Ah, this is from the last one too.
Well, what do you think it is?
Let me see. I'm not. I have no clue. Even short. Those that control the supply chain must make decisions such as time and cost. Hmm. Okay, it's not D. We- Three commonly used. It's not C. So it's gotta be A or B.
A or B?
A or B.
You gotta give me A or B.
Mm-hmm. The criterion to be minimized in the shortest, even though the shortest. I would go with A. An LP in which all variables are treated in is called an yeah, all integer linear programming. Solve as a maximization problem.
What do you think it is?
A. I think it's A.
Okay.
All supplies and demands are equal to 1, hence assignment problem may be solved as linear programs. Um, assignment alternatives are equal in terms of I don't know. I would say it's C. Wait, we're still at 11 question?
Yeah, we're
Oh,
not that
never.
far in.
What the heck?
Yeah, and we got like what, 30 questions on the final, so
Yeah,
you gotta speed up, my guy.
I know. Posterior possibilities decision is used. These revised properties are called. Out, these revised probabilities are called posterior probabilities. C. Good decision analysis include about a favorable as well as unfavorable risk analysis. X, Y, J. This is the one with the conditional. Project J is conditional to project I.
Mm-hmm.
Um,
Oh, by the way, when we finish this, when we come back from the break, we're going to be doing homework 7 first.
Okay. Depicts decision nodes. Is it circles?
Circles.
Yeah, circles and ovals. Uh, add an dummy agent to equalize the number of agents and the number of tasks. The object coefficient would be. I don't know this one.
Come on, you got this. You got this.
Uh, um, okay, okay. I'm just gonna take a guess here. I would say it's A. In a balance transportation problem. Oh, okay. This is a balance transportation problem. Mm, correspond to the states of nature. Uh, uh, an assignment problem seeks to correspond to the states of nature. I'm just gonna go with that. That makes sense. C. No, C.
Okay.
Wait, hold up. Go back. In the Okay, I think maybe I'll go with D. Never mind. D.
Why? Why?
Okay, because that also makes sense too. Yeah.
I
Yeah.
like how by clicking the wrong one, you die yourself.
Yeah.
Good to
Oh,
know.
no. Upper bound on the expected value of any sample survey information. EVPI. Shoot, in the maximum flow problem, each arc has a blank which limits the flow through the arc. Limits the flow. I would say arc flow capacity.
So close.
Ah, god damn it. Oh my god. What?
You know what? Don't worry about it. Go take your lunch break. We're gonna stop the stream here, and then we'll be back for
Wow.
another
I
four
still can't
hours and
believe it.
ten
That
minutes.
was okay. I can't believe. What did I miss? Jesus. What is this? So. Oh, okay.
Good.
Ah, okay. Yeah, that one. Yeah. Mm. Oh, okay. I mixed. Okay, okay. Okay. Oh, I got that one wrong. Oh, tell me. Oh, bro, I didn't read the C. I didn't read the C correctly. Oh, okay, okay. Yep, that's fine.
Okay, so I'm gonna cut the recording. We'll be back, and we got like 4 hours and 7 minutes to go. Anything you want to say?
Um, have a good lunch and study your vocabs and your terms.
Hmm.
Yep.
We'll be back in like 30 minutes or so.
Mhm. All right. Sounds good, man.